So we've reached the topic of literal equations. We need to keep in mind everything we've been learning about how to isolate the variable still applies. So let's take a look at what a literal equation really is. So we know what an equation is. It's a statement. A literal equation contains two or more variables. So we've been doing equations that have one variable, and we've been solving for that one variable. So if you take a look here, A equals BH, that's the formula for area of a parallelogram, or a square, or a rectangle. You also have A plus C equals D. All of your formulas, your volume formula, okay, those are literal equations. If you can solve a regular equation, you can solve a literal equation. Nothing changes. Remember, what is our number one goal when we're trying to solve an equation? Isolate the variable. Get that variable completely by itself, okay, with nothing else there. We're going to do the same exact thing that we did with literal equations. But this time, we're going to focus on one specific variable. And we're going to use our inverse operations to get there. So these three questions will help guide you when you're trying to solve a literal equation. So as we go through this, make sure you have these written down properly and that you're using them every single time. It'll commit it to your memory. So here's the first question. You have to ask yourself, what do I need to get by itself? What are you trying to isolate? Okay, and that would be the specific variable they mentioned. They have to tell you what variable you're solving for this time. Once you've identified that, you have to ask yourself, what do I need to get rid of? Meaning, what do I need to bring to the other side? What that's going to be is everything else. Anything that's not the variable. Okay? Your third question you ask yourself, how do I get rid of it? It's what is the inverse operation? So these questions will help you figure out what to move. Okay? But most important, we must keep the equation what? Okay, now that's why that popped up. It might help you realize what you do to one side, you must do to the other. That helps you keep your equation balanced. Okay, an equation's like a scale. Okay, you can't move things to one side without doing it to the other. So let's take a look. Notice we have our three questions here. The problem says solve for C. So what do I need to get C? Okay, I need to get C by itself. So you're going to circle it. Circle it so you know that you don't want to move. You don't want to move that variable. So now what do you need to get rid of? Well, looking at C, if I want C by itself, I have to get rid of A. Here comes your next question. How do I get rid of it? What is the inverse? Well, if you look at A, you have to be careful. The inverse right now would be subtraction because A is a positive. So I subtract A from the left, and I also subtract it from the right. What happens is I'm left with just C equals, and there you might have written this one way or another. I write what was already there. I'm doing D minus A, aren't I? So I'm going to write D minus A. That right there, that's it. I've solved for C. So some people get really stuck on this topic because you're like, wait a minute, it's not a number. Remember, variables represent a value. We just don't know it yet. So once we know those values, I could plug them in and work through this problem. So let's take a look at these. Okay, remember, keep those three steps. You have them written down. So I'm going to solve in this one for D. Do you notice how it says solve D plus 12 equals E for D? Okay, solving for D. Pause and try on your own. Let's see how you did. I like to rewrite it. It's going to help you. So I'm solving for D, meaning I want D to stay put. So what do I need to get rid of? I need to get rid of the 12. How do I get rid of the 12? By inverse operations. So I subtract 12 from both sides. That leaves me with D equals E minus 12. Okay, let's go look at my next one. It's asked me to solve for C. Do you notice how it says solve A equals C plus H for C? That means I want C to stay put. So what do I need to get rid of? I need to get rid of H. What is H's inverse? Subtraction. So A minus H equals C. Yes, we're building baby steps here, everybody. Okay? So you might get told, and it's another way of asking it, but you might get told, write in function form. Functions are inputs and outputs, and we're going to get to that coming up here. However, all that means is solve for y. If you're told to write it in function form is when y is by itself. So that means I want to get this y to stay put. So it's like solving the two-step equations we've been doing. I can't touch the y term. I need to move over this 2x first. Okay? So I subtract 2x from both sides. That is all one term. I can bring it over together all at the same time. I then get 2y equals negative 2x plus 10. You're going to see coming up in a chapter or two, I would say in 2 chapters, why we want to write the x term first. Okay, we want to write it in what's called standard form, our constants at the end. But now remember, y is not by itself. I still want to get y completely by itself. So I'd have to divide absolutely each thing by 2. Notice on this right-hand side, I drew 2 division symbols. There's a reason I'm doing this. Don't draw one big line and put divide by 2. Okay? Because then you can go through. What is 2 divided by 2? 1. So I have 1y. Now on the other side, I have negative 2 divided by 2. That's going to give me a negative x. And then I have 10 divided by 2, and that gives me a 5. Okay? So take a moment. If you need to pause, go ahead and pause so that you can get this written down. Okay. Here it is. Same instructions, write in function form. Your turn. Pause the video and try it on your own. Okay. So I need to get y by itself. That means I'm going to subtract 6x from both sides. I'm subtracting 6x because the 6 is positive. That negative goes to the 3. So that leaves me with negative 3y equals, remember I write my x term first, negative 6x plus 12. And I know it's a plus 12 because that 12 that was already there was positive. Now I need to divide each term by negative 3. So look how I'm writing it. Make sure you're writing it the same way I'm writing it, because this makes this next step easier. Negative 3 divided by 3 is y. Negative 6 divided by negative 3 would give me a 2x, a positive. And then 12 divided by negative 3 is negative 4. Take a look. Is y by itself? Yes, it is. That means you have written it in function form. Okay, so let's read this question. The slope-intercept form of an equation is y equals mx plus b. Rewrite the equation in terms of the slope m. So you have the ability to do this. Right now, I want you to pause and try to solve this for m. Okay, let's see how we did. We're getting m by itself, so let's circle m. I can't touch the x yet because that's multiplication. So the multiplication division, the last thing I do. So I'm going to subtract b from both sides. What happens is I get y minus b equals mx. So I need to isolate m by dividing both sides by x. So that leaves me with m equals y minus b over x. Now, a lot of you might be sitting here saying, why didn't we separate? You could have, but because nothing was a number, you can write it this way now. There's no simplifying that's possible. So right now, you need to summarize. You need to reflect. What did we do here? How's it different? How's it the same? If you don't understand something, leave a comment or like if you did get it.